Okay, we're going to look at the participation activities and the assignment since they're so closely related in this video for Unit 5. We're going to use a different neural network simulator called Neural Simulator. And that's listed here, and it's nice because it has a set of tutorials instead of including a bunch of sample projects that you can run. And we're going to be using one of these to classify breast cancer data with neural networks. So we'll be doing this model here. Before we can do that, we've got to get this simulator running. Now you can actually download the full version of this. This is a Windows application, and you can run it as a Windows application. It's all written in NetBeans, and it has a nice application here. This is what it kind of looks like, and you can do file and new projects and set it all up and run it as a Windows application. But this is a fairly large download, and so I'm suggesting you do a faster version of that, and that's the online demo here. So you can go to this website that brings you right here, and then you can hit the start button. It should so depending on what application you have, if you hit start, it'll either save the launch.jnlp file to your wherever your downloads folder is, or launch it. So like if I'm in Internet Explorer here, if I'm in Chrome, I know it downloads it. If I'm in Internet Explorer and I hit launch, I allow it, it'll download it and run it in Java. I have to allow this one too and set up. So this is what we want eventually. So we have to get to that point. So again, Internet Explorer, it should go relatively, basically start from there. Like Chrome, I haven't tried Firefox or Safari, but they should do one of these. So it downloads the launch file. So here's what I say. Download the launch file and run that if needed. So I can go run the launch file there. So here's my launch file, and I can just double click on that. Assuming I have Java installed on my machine, I can run that. Now, you may have be asked for, if you want to run this application, say yes, and run it and get to this point. Now, we've run into some places where, depending on your security settings, this won't run at all in either case. So if that's the case, if you can't get it to run, try to configure Java. So go to Windows All Programs. I guess you can't see my Windows, but I'm going to Windows All Programs, and I'm going to Java, and then configure Java is an application. I'll wait for that to start up. When that starts up, I'm going to go to security. And you can keep it at high. If it's at very high, I mean, you can keep it at high and put in this link here for where we're getting this application. Put that in your exception list here. So you can edit the site list, paste it in there, and hit OK. So if you have trouble running this application, try that also. Okay, now once we have this up and ready to go, we can start this breast cancer example. So read through this. This is taking breast cancer data from the Wisconsin Breast Cancer Database. It's a set of data, and then for so we have data from a set of tumors, and we have 9 different character measurements on those tumors. And then we also know if they're cancerous, malignant, or benign as our 2 results. So there's 2 possible classifications of these, malignant or benign. So we want to determine if they are malignant, if they're cancerous, based on this data set. And so at Wisconsin, they actually then did more tests on it to determine this. But we're going to try to just have, given this data, we're going to try to learn, just given this data, can the network predict if this is a cancerous tumor or not? So we have the data here. It has to be normalized, and it has been normalized and is available. It's available down in the assignment. I can't link a file into this participation link here. So it's down here with the assignments. And it's just data, and again, normalized meaning that some of these values may have been a value between like 0 and 80. And so they've all been converted to a number between 0 and 1. So we found the max of each column and divide all of them by that max. So they're all mapped to 0 and 1. And so there are 9 numbers for the factors, and then the last two numbers, 0, 1, are either this would mean cancer or malignant, I think. And then some of these are cancerous. If it's 1, 0, it's cancerous. So these are the two output values here. So that data is all there, and grab it from here, and it's been normalized. So, okay. So the data's already been normalized, and again, this is how we normalize it. We're not going to go into too much detail about this. Okay, and so the first thing we need to do is set up our training data here, and this is and read in that data from that stuff. So you can skip over this first thing with this new project here. We don't have to create a new project. We'll just create the networks directly with this example, and we'll get that in a sec. So we're going to bring in our training set here. So we're going to right click on the training, or click on the training here, do new training set, give it some name, cancer data, and we'll follow these same sorts of measurements here, where we've got 9 input units and 2 output units. So 9 input units and 2 output units. That'll map our data and leave that as supervised. It'll bring have our data here. Now we're going to load the data from a file. Hit load from data. Go out here and locate your file for us. So I've found my data, my BC breast cancer normalized data. Open that up and load that. Oh, it's also comma separated. If you remember when we looked at it, let's look at it again. It's commas in between there, so we want to make sure we have that as comma separated stuff. So switch this to the comma and then load the data in. If everything goes right, you should see a bunch of 9 inputs and 2 outputs here, and there's a couple hundred samples here. Okay, so that so we did this, we loaded the data, we grabbed the data file, we switched this to commas, and then again we brought in our data. It should look like this. So then you have to make sure you're saving, hit OK, and it'll save that data here. So now we're going to do our first training attempt, and so this is our first training attempt. We're going to create a new multi-layered Perceptron, and it's going to have 9 input units, 1 hidden unit only, and 2 output units for benign or malignant setup. So how we do that in our system is we'll do network new multi-layer Perceptron, and again we fill in our values here: 9, 1 hidden, and 2 outputs. Generally you always have 9 inputs and 2 outputs, and then we'll vary the number of hidden units some. And again, leave the rest of this. We want to use bias neurons generally and stuff, so hit create. Bias neuron, just add an extra neuron in here to help with some of the learning stuff, a neuron that's always on. So what you'll see here is you'll see our 9 inputs and then 1 bias that's always on, and same with the hidden layer, there's 1 unit and 1 bias, and then our 2 outputs here. Okay, so we've got that set up, and now we're going to try to train that data here with these initial parameters and see if it can learn things. So with this network, select network 1 selected, we're going to hit and again we should just have 1 set of training data right now, so we're going to hit train the system, and again we can be following this, so we want a max error 0.03 and then some learning rates here, 0.03 and 0.4 here, and then hit train, and it'll start training, and we'll see this error rate hopefully drop down some. So it is, we're trying to get a low error rate here, and with only one hidden unit, you're probably not going to get a very low training. In fact, you can kind of see what we've plateaued off. It's still going down some, so you can let it train, let it run for a while to see what kind of error rate you can do. But it might be challenging to get all the way down to 0.03 for this. And I'm going to create a new network. Again, we have 9, 1, 2, but I'm going to switch this to back propagation with momentum here and create that. So now when I do my training, I can do and my error rates, and I can enter values both for the learning rate and the momentum. So this is how fast we change the connections, the weights between this, and this kind of just shows as we change them, how does that learning rate change over time. So now we hit train and look at that again. So my training rate is not really, I mean, my error rate is not going down much anymore, so I can stop it at this point and check. The error rates in here are not matching exactly what I'm getting, so I'm never getting down to this 0.02 for this error rate here. But we can try out some data here. So let's try to follow through this. Like I said, now you can actually try some specific data in and test it out. So we've picked some values, and these again, this is the which patient maybe this would be, and this is the different data on that patient, and this is whether or not. So this first one is malignant, cancerous. And this is the data. So in order to do that, go back to your network here, set input values, and then you can just type in these values here, 0.8 space 0.7. You just have to have white space between them. In fact, if you want, you can, rather than just entering those, you can just copy those in. Now you don't want the results, you just want the input. So you don't want the last two results here, but you want everything else, and I can just paste that in here, hit OK, and that'll set up this layer to be appropriate, and then I can, it should determine if this is malignant or not. Now something, let's see. So now when I've run this, I've entered those values in here, and if this becomes active, it's cancerous malignant, and so it's predicting quite certain that it is with this data. And then I can grab this data here, and this one should be benign, non-cancerous. So I can again just set those input values here. It'll reset these values, and then it is relatively sure that this is benign. So it'll highlight one or the other of these. And again, this is showing their results. My results are a little different than this depending on the learning situation, but it's doing an adequate job at predicting this. So let's go down here and look at the second training attempt. Again, we're going to create a new neural network with 8 hidden units. And again, a back propagation with momentum set up. So again, we can create another neural network, multi-layer perceptron, and we'll have 9 inputs. Now we'll hit 8 hidden units, 2 output units, and switch this to back propagation with momentum, create that. So now we have our different networks here. Now you might have to watch, they might actually all be open here. So I'm going to actually close some of these things down. Okay, here's the current network 3. And again, I can train that. So again, here we've got our 9 input units are 8 hidden units, and our outputs units are either benign or malignant. And we're going to try to train this data. Again, we're trying to get the error rate down very low, and here's what they're using for their learning rate. And so you can actually, later on we'll try different things for that, but for train I can hit train. Again, I want to keep it there. I want the learning rate to be slower and the momentum to be a little higher, so it'll learn slower, more slowly, but hopefully more accurately. So, and I can watch it should drop relatively quickly right away and continue to drop down to a low level. And it'll be interesting to see if you can get it down as low as we wanted it to go. So we'll let that run for a while. So again, they're showing some of the error rates, and again, they're trying to test out our random values in here and see how it's if it's predicting them correctly and how well. So again, we want you to go through these first 5 attempts here, different types of networks, different kind of structure, and just report the error rate that you're getting when you're done. So run it for a while and report this total error rate value as we run it for a while. Okay, so now I'm getting down to almost 1 on this one. So. Okay, now then the last thing we want to look at is the assignment for this week. For the assignment, let's back up for a sec. So for the discussion, by Thursday, submit your error rates for the first 5 trials, and then you can start working on the assignment. By Sunday, submit either a question related to the assignment or this whole thing, an answer or suggestion related to working with this data, or your best error rate and configuration. So for 5, we're going to continue here, and we're going to jump down to attempt 11 in the tutorial. So if I scroll down to attempt 11, now we're going to work with breaking the data into 2 parts, a training part and a testing part, and setting those up. And this is very common to break our data, and we generally want to test it on data we've never seen before. So if we have a set of data, we'll break off some of it just for testing. Networks are very good at learning exact data and replicating that results, but sometimes have trouble with new unknown data. So that's why we want to try to set this up. So we want to break our data up into 2 parts, a training part and a testing part, and work with that. So again, you can take your data file here, bring it into some editor, and break it up to about 80% in one and 20% in the other part. So here again, we're going to break the data up. 80% is about 560 records, so I'm going to keep the first 560 records here. And again, you can use whatever editor you want. I'm just grabbing Notepad Plus because that's what I have. So I'm going to leave the first 560 and grab the rest of it and cut it out of here and create a new document, paste that in here. So I'm going to save these files as like BC normal 80 and BC normal 10 or something like that. No, 20. So again, save these 2 files. Then you can bring them into your area. Remember when we did our training data, just go new training set and give it some name. Again, we're always going to be doing 9 inputs and 2 outputs. And again, then you can load it from the file, and then you can choose your file that has only those values. Then load those in. Remember to change this because there's a comma separated data, and load these in. And so you should have one set of 80% training data and another set of 20% testing data. And then you can run any one of your networks, whatever in maybe your best network, through this. Uh, Run it through the training data first with some training values, and then run it through the testing data. Just make sure when you run it through the testing data, you set the learning rate and the momentum to 0, or either one. So because we don't want to learn anything from the testing data. And then again, report your best result. Report your error rate for the 80% training data and the 20% test data. And one of the big questions is that now if this is data we've never seen before, can we still predict it relatively accurately? We should be able to get, with the training data that we've seen, we should be able to learn that really well. But the question is, how well does that generalize to new data we've never seen before? Okay, so report the network you used and then your error rates that you got for that. Hope you enjoy this activity.